Hello, this is Sal. Today's video we will be talking about GRE. GRE, Generic Routing Encapsulation. It's a tunneling protocol developed by Cisco Systems that can encapsulate a wide variety of network layer protocols inside virtual point-to-point links or point-to-multipoint links over an Internet Protocol network. A GRE tunnel is used when IP packets need to be sent from one network to another without being parsed or treated like IP packets by any intervening routers. Here in today's lab, we will configure an encrypted point-to-point GRE tunnel and verify that network traffic is using the tunnel. We will also configure the OSPF routing protocol inside the GRE VPN tunnel. The GRE tunnel is between router 1 and router 2 routers in OSPF area 0. The ISP has no knowledge of the GRE tunnel. Communication between router 1 and router 2 routers and the ISP is accomplished using default static routes. Now, we will start configuring the interfaces on the router. As you can see here, I did not configure anything, just this topology, and in the description of this video you will find a file to download packet tracer for this lab and also a walkthrough documents. It will show you how to do everything step by step until you verify that you can ping from PCA to PCE on this network, and when you run the trace route from PCA to PCE, it will show you that the traffic is being encapsulated, and you will not see the path will be straight from router 1 to router 2 and then to the network. Here on router 1, I will configure the interfaces. First, let us type no here, and then in enter, configure terminal host name. I'll give it the name router 1 here, and now interface. The interface facing the network, you give it Ethernet 01, IP address of 192.168.1.1 with /24 subnet mask, and no shut to open the ports or no shutdown. Now the interface facing the ISP router on serial 000 and the IP address of 10.1.1.1 / 30 255.255.255.252, and also here no shut. Now go to the ISP router. Now here, enter, enable, configure terminal host name, ISP, the interface facing router 1, serial 000, IP address of 10.1.1.2 with /30 subnet mask of 255.255.255.252, and open that port with no shut or no shutdown. The interface facing router 2, serial 001, IP address of 10.2.2.2 with /30 subnet mask 255.255.255.252, and no shut. Now going to router 2. Now here, enable, configure terminal host name, router 2, and interface facing router, the ISP router, interface serial 001, the IP address of 10.2.2.1 /30 subnet mask, and no shut to open the port. The other interface, big 01, IP address of 192.168.2.1/24 subnet mask and no shut or no shutdown to open the port. Now we configured the interfaces. Now let's configure the PCs here. PCA, as you can see here, this is the IP address we want to configure for PCA. IP address of 192.168.1.5, subnet mask is 24, and the gateway is 192.168.1.1. This is the gateway here, this interface of the gigabit 01, and that's it. This is for PCA. Now PCC, click on the IP configuration and the IP address of 192.168.2.5/24 subnet mask and the default gateway 192.168.2.1. And here we configured the PCs. Now on router 1 and router 2 to configure default routes to the ISP router. From here we will configure a default route to the ISP router and the same from router 2. So on router 1 we will IP route a default route, and it is 0000 and 0000, and the interface /000 here is the next hop or the gateway for router 1. So you want to talk to the rest of the networks, this is the gateway of router 1 and the IP address of 10.1.1.2. Now we'll do the same on router 2. Configure the default route, IP route 0000, and with zeros for the subnet mask. And for router 2, this serial of 001 is the next hop or the gateway for router 2, the IP address of 10.2.2.2. 10.2.2.2. So now we configured the interfaces on the routers and also the default route from router 1 to the ISP router and from router 2 also to the ISP router. Now it's time for us to configure the tunnel between router 1 and router 2. We will use the tunnel interface on router 1 here. This is just to show you that this is how we want to configure the router from router 1 and router 2, but the traffic, it will be encapsulated and go through the internet through the ISP to router 2. So to configure the tunnel interface on router 1 will be this interface, serial 000, and the tunnel source interface, an IP address of 10. This is on router 2, 10.2.2.1. Now on router 1, here, the command will go like this, interface. Now we want to configure a tunnel. So for the tunnel, we want to give it a number. So we choose 0 as a number because it's allowing us to start from 0 to this, God knows how many digits here. Now we configured, now the state changed up for the link 5 changed, interface tunnel 0 changed state up. Now configure the IP address. As you can see here on router 1, this is the IP address 0.92.168.10.1/30. Also on this is the source from router 1, or the IP address here of 192.168.10.1 and /30 subnet mask is 255.255.255.252, because we want only this configure only 2 IP addresses for this tunnel from here to here, from this interface to this interface. Now the tunnel source. Sorry, I was supposed to type the word after IP address. Okay. Now tunnel source. Where is the source? The source for the tunnel, it starts here on this interface slash serial 000. Because packet tracer, we can either use the IP address or the name of the interface, but packet tracer allows us, only to use the name of the interface for the source as serial 0000, but you still can use either the IP address for the interface or the name of the interface. Now tunnel destination. The destination is this interface here on router 2, which is serial 001. We'll use the IP address of 10.2.2.1. 10.2.2.1. As you can see here, the line protocol on interface tunnel 0 changes state to up. Now let's do the same on configure the tunnel interface on router 2 here. I'll use serial 001 here. As I said earlier, that you can either use the IP address or the name on the interface, but packet tracer does not allow us to configure the source IP address, only the name. And this is what I'm gonna be doing here. Interface tunnel, and as I said, it is giving us the option to start with 0, so we will give it simply, and just to simplify the process here, 0. And now the IP address for the tunnel on router 2 is this IP address of 192.168.10.2 with /2430 subnet mask. Enter. Now the tunnel source is the interface of serial 001. This interface here, tunnel interface, the source, tunnel source. Sorry about that. Tunnel source, serial 001. Now the tunnel destination, which is on router 1, this is IP address of 10.1.1.1. 10.1.1.1. So we configured the tunnel on both sides on router 1 and router 2. As I said, I need to mention this again. As for the tunnel source interface, we can use either the name of the interface or the IP address on the interface. The packet tracer does not support using the IP address as a source, just in case you have this question in the exam. Now, on router 1, I need to run this command here. Let me type in here, show IP interface brief. As you can see here, for the tunnel, we have this IP address for the tunnel on router 1, and it is up and up. I will run the same command on router 2 also. Show IP interface brief. As you can see also here for the tunnel with this IP address, and the status is up and up. Also, let me run this command on router 1 and router 2 to verify the tunnel protocol here. And this command is show interface tunnel, and our tunnel here is with number 0, as you can see here. This is the command show IP interface 0, showing us that tunnel 0 is up, line of protocol is up, and it is connected. Hardware is tunnel. The internet address on router 1 is 192.168.1, the 10.1/30, and the bandwidth, reliability, and encapsulation, it's using tunnel. We did not set any loopback, and the tunnel source is 10.1.1.1, which is this interface here. On the serial 000, the destination is showing us this IP address here, and we can run also the same command on router 2, show interface tunnel 0, and showing us, this is the command again, show interface tunnel 0. The tunnel 0 is up, line protocol is up. This is the IP address for the tunnel, and the source, this is the source from router 2, 10.2.2.1, and on serial 001, the destination is this guy here. So this is simply the command show interface tunnel 0. Now let's run the ping from router 1 to router 2. Ping 192.168.10.2, and we received a reply. And now I will use trace route 192.168.10.2, and showing us just the traffic moved from here through the tunnel here. It did not go all the way up to the ISP or here. It is not showing us this route because we are using the tunnel, the GRE tunnel. The traffic is encapsulated within the tunnel as we configured it from router 1 to router 2. Now we will configure OSPF routing over the tunnel. Now on router 1, or let me run this, the ping from PCA here on PCA to ping its interface 192.168.1.1, and we receive the reply. We're pinging the interface for the gateway for PCA. Let's see if we can ping PCE 192.168.2.5, and it is not, it will time out on us. Now let's configure OSPF routing over the tunnel. So what we will configure, 2 networks. We will not configure anything in the 10 network, not this interface or this interface or this interface. We'll configure the network of the tunnel 192.168.10.0/30 here, and this network here 192.168.1.0. So on router 1, configure terminal, router, OSPF, and the process ID 1. So we will configure only, as I said, 2 networks. the network of 192.168.10.0, which is the tunnel for the IP address for the tunnel, and the inverse subnet mask of 000.255 and in area 0. The other network of 192.168.1.0, which is this network here, and the inverse subnet mask of 000.255 in area 0. Now let's do the same on router 2. Configure terminal, router OSPF, access ID 1, the network of 192.168.10.0 with the inverse subnet mask of 000.255 area 0, and the other network of 192.168.2.0 with the inverse subnet mask of this area 0. And as you can see, it established the network here. You can see its neighbor from this side to this side of the network. So now let me run this command on router 1. As you can see here, also the adjacency between the two routers, router 1, router 2. So here, let me run this command, show IP route. We have this, the route which we configured earlier, and for O, which stands for OSPF, as you can see, it's 192.168.2.0. This is from router 1 to router 2. This network here, /24, we can reach it via the tunnel 0. The same on router 2. And here, show IP route. Also, here as you can see, O stands for OSPF, the routing protocol. So for this network here, we can reach it via the tunnel, not via the internet. So the traffic will be moving from router 2 to router 1, or from router 1 to router 2, being encapsulated through the tunnel. Now, let's here we configured the I'll ping from PCA to PCE, run the same command again. As you can see now, we can ping from PCA to PCE. I'll run this command, trace route 192.168.2.5, and notice here, first the traffic moved to its gateway to here, and then through the tunnel to here, and then to the host. There is no mention of it going over the 10 network through the ISP or through the internet. And we can do the same from PCE. Here, ping 192.168.1.5, and I'll run this command, trace route to the same host, .1.5. As you can see, I'll expand this a little bit, that it went through its default gateway, traffic from here through the tunnel all the way to the PC. So the traffic was encapsulated. It went through the internet, through the ISP, but the ISP router didn't know anything about the traffic, because the traffic, we configured GRE through the tunnel for the traffic to go through the tunnel from router 2 to router 1, or from router 1 to router 2 through the tunnel. And the traffic is being encapsulated, but in a clear text. It's not encrypted. So this is GRE, very simply, just keep it simple, to understand and read if you want some more about it. But this is, you can download the packet tracer source files for this topology, and also the documents to walk you through step by step. Everything I did in this video, you will find it step by step. And I hope you will learn something or two, or a tip or two, from this really simple video about GRE. Please, if you like the video, share it and give me the thumb up, and I'll see you soon in my next video. Thank you so much.